Hello people, welcome to this new video in which we are going to program an RF module, the module NRF24L01 with a PIC microcontroller all programmed on MPLAB XID using the XC8 compiler, the last version 2.3 and MCC, the MPLAB code configurator, and all that with the help of a library that I will leave you the link on the description, and this is how it's gonna looks like. Hello everybody, in this video we are gonna see how to use one of these NRF24 modules with a PIC microcontroller to make a communication between two of these. First than anything, we have to know these modules. Like you can see on the screen, this is the module and these are the features. It works with 2.4 gigahertz. It has 126 channels in which it can work. It's a transceiver, that means that it can work like an RX or TX, just one at a time. It works with this kind of modulation, is the JFSK. It can work at 3 different speeds. This is the transmitter power and more feature here. It has a payload from 1 to 32 bytes. You can configure that payload, and we can have a saver with up to 6 modules. It uses 1.9 volts, from 1.9 volts to 3.6 volts. Normally, or microcontrollers like most of the Arduinos and most of the PICs from 8 bigs use 5 volts, so we can use one module like this one to adapt that voltage. And if you don't have that modules, there is a lot of PICs that use 3.3 volts too. Like I'm using the PIC 18F25Q10, which can use from 1.8 volts to 5.5 volts, so it's perfectly for me. But I'm still using 5 volts, but I have the possibility to use 3.3 volts and without having the need to use that module. And this is pretty much this is 5 volts tolerant too, using the communication, because these modules use the SPI protocol of communications to interact with the PIC. Okay, we are gonna use for this practice the PIC 16F1842 and the PIC 18F25Q10. Make sure your code configurator is updated and your MPLAB XID is updated too. Okay guys, like you can see, I have the MPLAB XID 5.4, and if we go to tools, plugins, like you can see, I have the version as 4.02 of the MPLAB code configurator, so make sure you have at least the same version. First, we are going to create a new project. In my case, I'm using the PIC 18F25Q10. This is for the TX. First, we are gonna configure the TX, okay? And we are using the PIC3, using the last version of XC8, which is 2.3. And I'm gonna change this, and it's gonna be the X25Q10. Now I'll leave you a link there in the description below from these three files are gonna be our library. So download these 3 files. I got these 3 files here. Just copy them and go to your project and place these 3 files there. Okay, now we have to add these files to our project. Just click it, the right click, add existing item, and we have to go to our project, this one, and this is, we have to add all the headers, which are the red ones. And then in source we have to add the another one. Look at this, it's point C, and these are .h. We have to add .c on the source files. Okay, now the next is so easy. So we are gonna click on MCC code configurator. It's gonna take for a little while, all depends on how fast is your PC. Okay guys, so first than anything we are gonna configure this peak. If you want a video about how to configure this peak, let me down in the comments now, and I'm gonna make a video about this. First than anything, I choose this, the internal oscillator, and it's gonna work at 18 megahertz. It's so easy. Then I disable this to be able to disable the master clear. And like we know, this module works with SPI communication, so just add this, and let's configure this. We leave this one like that. SPI master, SPI mode 0 is okay. This has to be at the end, and we can leave this frequency is okay. It doesn't matter, just has to be above 10 megahertz. If it's over 10 megahertz, there is gonna be a problem with the communication, but like 4 megahertz is not. Next, we're gonna need an interruption into the falling edge, where we just need one interruption. So in my case, I'm gonna use this one, and I'm gonna disable the other interruptions here. I don't need these interruptions. Okay, so now I have the SPI protocol, I have the interruption. What I need more, I need to define what is the pin for each thing. Let's go here, MSSP. This one is gonna be, this one is okay, this one is okay, and this one I'm gonna put this one here. Okay, then we go to pin mode. Make sure that unclick this square of analog, and something that you have to know is that from the communication of SPI, it has more pins like you are seeing. Okay, we have the CE and the SCN that you have to connect like you are seeing in the screen. So I'm gonna use for that the pins RC1 and RC2. Both of these are outputs. Okay, unclick the analog again, and this is so important guys, put the names. Just put the names like I'm doing right now, because the library has these names target to use it on the library, so you are not gonna have to put anything else. Just put that the name CA and SCN, and the library is gonna know. I'm gonna use this one because I put one LED to know when the data is being sent, so that's why I have the LED declared there. Let's see this back. We put our SPI, we configure the SPI. Take a look, we configure the int0 interruption in the falling edge, and we configure our peak, disabling the master clear and working at 16 MHz with the internal oscillator, and we declare CE and CSN for the communication protocol of the SPI that we need to work with that module, and we add two LED pinout for all these are pinouts, like you can see here, unless the interruption, well, and the SDI. But I use the LED to know when the data has been sent or not been sent. And then we click using generate, wait for a little bit, and when the code has been generated, here's gonna be, it's gonna say complete, and then we just click on MCC and we go back to the another, and we go back to programming. We have here the pinout. GND is the ground, the VCC 5 volts, and the other pins are for the communication. The the IRQ is the interruption. This is gonna be connected for, in my case, it's gonna be connected to the pin of the interruption B0. CSN and CE are the pins that we declare, and these are gonna be for the communication. SEK is the MOSI and MISO are from the SPI communication. Also the CNS is for the SPI communication, is used for select your slave, and the CE is for the activating the transmission or for activating the module. We see here the main file that the MCC generate for us, so we just open that. In this case, I remember you that we are doing the TX, so like we have to uncomment those lines to enable the external interruptions. It's so easy because we are using the interruption of the module to know when the data has been sent. What's next? First, we have to add with the include. Just press Ctrl and space, and we have to add our libraries because there is where all the magic happens, or magic wand. Okay, let's go to see how to open our SPI. It's so easy. Just go here, looking for our SPI, SPI1, and this is how to initialize, and we have to open our SPI. So we copy that, and we have to put inside SPI1 default. So again, copy and paste. Okay, next, then we have to define our interruption. So let's go to the interruption xint, sorry, and we need to find out this one, int setup handler. This helps us to put okay, this when the interruption occurs on the microcontroller, it calls to this function, and this function is gonna call the function that we put here. It has to be ISR because on our library the function ISR is this one. So we need to put this interruption in order to be called and the code works. If you don't put this part of the code, obviously this is not gonna work. So make sure, guys, you put this like that. Both things have to be like that, at the same. Just copy and paste, like what I put there, just copy and paste that. We have to create our payload, and the size of our payload, yeah, like I told you, it can be from 1 byte to 32 bytes, but you define that on the library. Here we decide the length of our payload, so we just copy that for make sure that this has the same length, and I just put it there. Before to continue, we have to know our library. Let's take a look. This is the library. We can see in which channel we can move this. Okay, I have this one because I have my modules working in this channel, which is the channel 2. My payload is 32 bytes. You can move that too. It is working at 1 megabytes per second, and this is the more stuff for the setup, like how much power and more stuff. Here you can see some direction for the TX. That's why I told you that we have to put CE and CSN, because as you can see, it takes that from the library, so you don't have to move anything else, you don't have to put anything else. And here are all the functions that we have to use. We have to init our library, so we copy this one and we paste this one right here without this, obviously, and this. We have to configure this module like RX, so let's copy here, just copy and paste the same, and inside we have to put like here in which direction we want to configure this. Just copy from here the first one, or wherever you want, and paste. We need to wait between each of these configurations, so we put a delay. I think 15 milliseconds is okay for both operations. We have this model configured, we need to start sending data. For make sure that the data that I've been sending is okay, like I'm not receiving another thing that I'm not sending, I'm gonna pay in my payload. Right, so now we just have to send the data, which is so easy. We go to here and look for the function to send data, which is send which is this one. Let's copy all the function, okay? Right, okay, length is the same length of the payload, so we just replace that, and the value is our payload, so we just put our payload there, and that's it. The data is gonna be sent it, but we're gonna put a delay to make it more easy. I want a delay from 1 second, and I have to make the LED link, so I'm going to go to the pin manager and copy this LED toggle, just paste link toggle, and the LED is gonna change from state. I'm gonna make it a little bit faster, and that's it. In my case, I'm using the Picky tree to supply my project, so I have to go through Picky tree, power and activate the 5 volts. I told you I'm using these modules, that's why I don't need why use 3.3 volts, but I can use 3.3 volts if I want, but I'm not using. Let's compile. Like you see, all is okay, and just download it and just program. Okay guys, I'm gonna change this to 50 millisecond each time. In total it's gonna be 100 millisecond because I'm gonna send a lot of pulses from one model to another one. I'm gonna show you the example of the reception of the RX to don't lose much time. I got one prepared. The same include our libraries, initialization our system with this. On the MCC is exactly the same. Anything changed, okay? The only difference is here. The same, unsigned charge. This is not necessary, it's just for see the status of the module, so it's not necessary to put that. Init 50 seconds. In this case we are using this now, the RX configuration. Another thing, make sure you have here we can see this is the register. For default the program use the first byte to write the 5 bytes, so just modifying the first byte, the program are gonna use this and reply 5 times. That's why I'm just changing this first. You can put which you want, I will leave it like that, but you can put whatever you want. Just make sure in your both modules are using the same address. This is so important. These modules has an address. You can configure two address. One address is for the RX and the another address is for the TX. The address for the RX has to be the same all the time, and the address of the TX can be changing. It depends on with which module do you want to communicate. Here we can see it's called data pipe, the data pipe 05. In this example, the PRX is receiving data from 6 different modules. Like we can see, each module can save 2 pipes with five bytes, different bytes, and the data pipe 2, 3, 4, and 5 needs to have the first 4 bytes has to be the same from the data pipe 1, and the last byte, which is the byte 0, can be stored different to have like a different an address from the data pipe 1. This is the example. We can see here, this is an example when you want to interconnect more than 2 modules. Here we can see the data pipe 2, 3, 4, and 5 has the same first 4 bytes, is B3, B4, B5, B6, and the last byte is the only one that change to have a different address each one. In our case, we are just using 2 modules, so we can use the same address. Like if we put here just 7878 and here 7878, it's not gonna have any problems. Even if the both of that modules are using the same address, we are gonna have any problem because just one is speaking at the time and there is not gonna be any confusion. So for make it more easy and we are just doing easy communication without any complex coding, so we can use in both the same address. Another thing, we are not using the auto acknowledgement, is used for send data back or for make sure that the DX send the data to the RX and it's being received, so the RX send 1 bit or more bits back to the TX to let them know that he receives all the data. We are not using it for make it more easy to use. That's why this communication is so simple. If you want a more complex communication, watch the next video. Go down, the same, let toggle. I put this one just for initialize my modules. In 1 second it's gonna blink, just for let me know that the system is getting activated. And this is the function you're gonna use. While in the while we are gonna wait from some payload is received, and when the payload is received we are gonna save that payload here on this variable payload, the same variable, like you can see it's the same payload. And we have to corroborate that this data is the same. I changed the data in the last example. I put another one. I moved this from the payload 0 has to be 17 and the payload 1 has to be 19. From the example I just correct the last one. Let's go from the last one to see. Here we go. I put this one, it has to be 17 and 19. That is the only thing I've changed. And also I put this inside, but it's not necessary at all. I just put inside that. So let's go back. So that's it. That's all you have to do, and just download and it works. Of course there is a lot of ways to make it more professional, to make it work with more modules. It's more difficult because you have to change the direction from the module in which you are sending, and when you are receiving from more than one module you have to check from which direction or from which address are you receiving that payload. If you want me to make a video about it, just let me know on the comment below. I have another code in which I connect 3 different modules and they can speed between them. I think it's an easy way to set up these modules. We just need like 10 minutes or less than 10 minutes to put these modules on working. It's nearly like Arduino using those libraries and the MCC. So let me know what you think about it. If it works with you, if it didn't work, why, if you like the library, let me know down in the comments. Thanks so much for watching these videos and I will see you next time.